Hey everyone, today I'm going to be talking about Python powered infrastructure as code. I'm going to tell you a short story about using one stone to kill two birds. I'm going to introduce you to a girl named Amarachi. She lived in Lagos, Nigeria. She was a rising star in the world of technology, known far and wide for her expertise in artificial intelligence. Her days were filled with lines of code, algorithms, neural networks, and she tirelessly worked to push the boundaries of AI development. Amarachi has always been fascinated by the endless possibilities of technology, and from a young age, she had a knack for programming. As she grew older, her passion for AI deepened, and she decided to pursue a career in the field. After completing her computer science degree, she joined a cutting edge tech company, Synth AI, as a junior AI developer, and she used Python for her work every day. At Synth AI, Amarachi was surrounded by some of the brightest minds in the industry. She soaked up knowledge like a sponge, always eager to learn and innovate. Her dedication soon paid off as she rose through the ranks, becoming a respected AI developer within the company. One day, while attending a tech conference, Amarachi stumbled upon a workshop on cloud computing and infrastructure as code. The workshop was focused on a tool called Pulumi, which allows developers to manage cloud resources using familiar programming languages like Python. And Python is something that Amarachi is very comfortable with. Intrigued by the potential of Pulumi, Amarachi decided to dive into this new world of cloud development. She began studying Pulumi's documentation and experimenting with its Python SDK. Amarachi was quick to grasp the concepts, and before long, she was using Pulumi to automate cloud infrastructure for Synth AI's AI projects. With Pulumi, she could provision servers, manage databases, and configure networking resources with code, all while leveraging her Python skills. As Amarachi continued to explore Pulumi, her proficiency in cloud development grew rapidly. She designed scalable cloud architectures to support Synth AI's AI models, and she ensured that they could handle vast amounts of data and complex computations. Her colleagues were impressed with her newfound abilities and admired her dedication to expanding her skill sets. With her dual expertise in AI and cloud development, Amarachi became an invaluable asset to Synth AI. She seamlessly integrated AI models with cloud services, creating AI powered applications that could scale effortlessly to meet customer demands. Her work not only improved the efficiency of existing projects, but also opened up new opportunities for the company. Amarachi's reputation as a trailblazer in the AI and cloud development space continued to grow over time. She started talking at conferences and writing articles for tech publications, sharing her knowledge and inspiring others to follow in her footsteps. Her journey from an AI developer to a dual skilled AI and cloud expert was a testament to her passion for technology and her unwavering commitment to pushing the boundaries of what was possible. All around the company and in the entire tech ecosystem, Amarachi's name became synonymous with innovation, and her story served as a reminder that in this ever revolving world of technology, the only limits were the ones we set for ourselves. With her AI and cloud skills, Amarachi continues to shape the future, one line of code at a time, proving that the possibilities were limitless for those who dared to dream and embrace the ever changing landscape of technology. Amarachi used her programming skills beyond programming, and now she's a thought leader both for AI and cloud development. And I'm here to show you exactly how to be like Amarachi. You might be in the AI space, you might be in the data space, you might be a back-end programmer, you might be in the fintech space. In whatever space that you are in, you can be the Amarachi of that space. And this talk is exactly about that. But before we get right into the talk, I would just want to introduce myself. Hi, my name is Adora, and I'm a senior software engineer currently working at the intersection of cloud engineering and developer platforms. I am the founder of Nexa Scale, which is a social enterprise currently helping people start and scale their tech careers. I've won so many tech awards, so some people call me an award winning tech woman. I'm a speaker, I've spoken at different conferences all around the world, virtually and physically. I am a published author. I have written two books on cloud engineering, and the goal is that eventually someday I write more. I recently finished from the Stanford Graduate School of Business, so it's a fresh achievement. So it's going to be in a lot of my bios for the next couple of months, and it's something I'm really proud of. A couple of months ago, someone in the ecosystem did an introduction and introduced me to someone in the US, and he called me an ecosystem advocate, and I thought about it for a bit, and that sort of made sense to a bunch of all the community things that I do. So I have decided to start calling myself an ecosystem advocate, so that's why that's there. And I am passionate about tech, community, and education, and I really, 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 really love music. Listening to music, making music, mixing music, analyzing music. I love music. So now let's get right into it. As we know, cloud innovation is rapidly growing, and managing resources have gotten more complex over time. There was a time when everybody was doing FTP deployments, and you didn't really need to care about different things. You would just zip your code and deploy it to a server. People had like different servers they were using at that time, and that was cutting it. That situation worked for the kinds of problems we had at that time, and people were doing a lot of things manually. And now we've also moved into the cloud era, using cloud providers like AWS, Azure, GCP, all of that. And for a while, a lot of people were still doing things manually, and some people still are today. But the truth is, manual configurations don't cut it anymore. And as a DevOps community, I want to believe that this is something that we all know. With manual configurations, your deployments are slower because mistakes can be made. Everyone is relying on the documentation. So if somebody goes to configure infrastructure and they forget to document that, the processes and all the things that was done and the way it was done, there's definitely going to be an issue. There's larger risks of errors if you are trying to create infrastructure that is supposed to mirror other kinds of infrastructure, because people make mistakes and you don't want to leave the knowledge of a particular system only to one person that knows the system. You want it to be documented somewhere. Rollbacks require manual work as well. So if there's any configuration that you make and there is a problem, you have to manually undo what you've done. There's another problem called configuration drift, which is a serious and annoying problem, especially in the context of DevOps. And I'll give you an example. Let's look at these three environments. They sort of look alike, right? We have situations where our development environment is mirroring our staging and our production environment. So they all look alike. What this means is that if I deploy to development and I test in development, and I deploy to staging and I test in staging, because these environments look alike, the chance is that if I deploy to production, because it works in staging, it should work in production as well. Obviously, as your application scales, these might look different, but this is for a basic application. Deploying to dev, to staging, and production, if they all mirror each other, the behaviors should also mirror each other. The problem now, right, with manual configurations is that over time, you start to change things little by little, and you don't realize that you're changing things because maybe something happened in your production environment and there was a problem, and you went to quickly fix the problem on the portal that wasn't documented anywhere, and now your production and your staging no longer look alike, and this can create problems for you, maybe not now but in the near future, right? So we have a superhero that saves the day, and it's called infrastructure as code, and it fixes these problems for us. And with infrastructure as code, our configurations are specified in code. We can automate our infrastructure deployment, we can test, version, and roll back our infrastructure, and we can use our transferable skills from programming. because infrastructure as code allows you to create infrastructure declarations writing regular code, right? So I can write C sharp, I can write Python, I can write Golang regularly, and I can use those languages which I already know to create Azure VMs, to create a container registry, to create networking resources, virtual nets, networks, subnets, network security groups, and different things that I need to make my application to run. I can do all of this by writing Python, by writing C sharp, by writing Golang. And I'm going to be using a tool called Pulumi to show you exactly how to do this today. Pulumi is an open source infrastructure as code tool, so none of those underground licensing things. It's completely open source. And the amazing thing about Pulumi is that you can use familiar programming languages with Pulumi. So you can write C sharp with Pulumi, like I said. You can do Python. Once you have the Pulumi SDK, you can use Pulumi to configure infrastructure using, languages that you use every day. And some of the languages that they support here are TypeScript, Python, Golang, C sharp, Java, and YAML. So now I've told you about Pulumi and I have told you about the problem that we're trying to solve. So we're going to do some coding, right? I will create a Pulumi project. I will write some Python and we are going to see how we're able to use this Python code to create resources in Azure. Okay, so I am now in my CLI and we have to come here first because I need to interact with the Pulumi CLI to create all of my Pulumi project resources and things like that. So for me that I have Pulumi installed and things like that, I don't have to go through the step of installing Pulumi. But if you need to install Pulumi, then you need to go and install Pulumi and come back. So now let's create a directory called Python IC. And then we can also cd into that Python IC directory that we've created. Now we are in a new directory that we've created, and it is in this directory that we would create our Pulumi project. So now let's go and run Pulumi new serverless Azure Python. And Pulumi new is a way to create a new Pulumi project. Let me show you the different offerings that they have even before I do my serverless Azure Python. So let me just type Pulumi new and hit enter just so that you can see what happens when I do. So you have different ones, Auth0, AWS, Azure, containers, different things. You have different ones, GitHub. So like there are different providers that they support and there are different projects for Pulumi that you can create. So since we're actually already here, I can actually just go to serverless Azure Python like I wanted. So I want to create a Python program to deploy a serverless application to Azure. So Pulumi new serverless Azure Python. I want the name to be Python IAC, so I have nothing to change there. I would leave my stack as dev, and stack are pretty much environments. We know that at the beginning of this talk, when I was talking about dev, staging, and production, you can use stacks in Pulumi to manage your environment. So you can have a dev stack, a staging stack, and a production stack for a very basic cloud infrastructure, right? So I'm leaving my stack name as dev, and my region can be West US 2, that's fine. The path to the app. So two things are going to happen in this serverless provider offering that they've given me. So first of all, there's going to be a serverless function that will be deployed, and they're asking for the path of that serverless function, which is app. I'm fine with that. And there's also going to be an HTML project that will trigger that serverless function getting called. So they're asking for a file that I should use for error pages in case maybe there's an error page or something and error.html works. they're asking for a file that I should use for index page, which is index.html. That works. So on the index.html page, that's where I would that's the page that has the website that calls the actual function that we want to get deployed, and it's asking for the file path, the path of the site. So the www folder is what would have the error.html and the index.html, similar to how you have a front end and you have a back end in the same repo. So that's actually the kind of setup. And then you also have Pulumi deploy your front end and back end for you in that same repo. And we're going to see all of this in action with Python. So it saved all of my configs and it is creating all my Pulumi resources. So let's just wait for it to be done. So now it is done. I can run Pulumi up from here, but I actually want to show you my Visual Studio Code so that you can see what it looks like before I even say, let me run Pulumi up. So let's go there. So we're in Visual Studio and we have our Pulumi project. How we specify Pulumi projects is this pulumi.yaml file. So this pulumi.yaml file is what helps us know that we are in a directory that is a Pulumi project. The similar Python setup, we have our virtual environment folder here. We have our requirements.txt and we have the main.py, which is the entry point. So now this main.py is actually the Python code that is creating our Azure resources with Pulumi. As you can see here, we're creating an Azure storage account. We're creating a static website. We're creating an Azure blob, a blob container. We are creating an app service plan. We are creating a web app, and we are also creating a storage blob. So now I'm going to name my resource group something unique so that we can find it in the Azure portal when it's time. But before I even do that, I want to show you the website. So this is the error page and the index page. So this index page, what it's actually doing is the serverless example is just asking for the time, and the index page is returning the time. That's pretty much what it is. So it's saying, so this is the script that when you click, get the time is the name of the function, right? So there is a get the time function here that when you click on it, it calls the API. And the serverless API, the name of the serverless function is data. And I'll show you how the name is specified in a second. So the name of the serverless function is data. It calls the serverless function. Sorry about this. It calls the serverless function, gets the response, and returns the time back. So that's what happens here, right? So now let's see what happens in app. In the app folder, there's a data folder. So this folder is the folder that contains all of the functions. Right now we have only one function and it's called data. So, and how we know is we have our host.json, which is, what helps you know that this is an Azure functions folder. And inside this folder, we have our function.json, which helps us know that this particular code inside this folder is an Azure function. And this is where the script init.py is written. So here what we're seeing is that we have it returning the time for us. So it's saying now in MS, it's asking for the time, we're getting the time back, and we're returning it. So you can see all of this happening. I'm going to open my terminal now. And let's run Pulumi up and have this thing deployed so that we can see what happens. But before we run Pulumi up, actually, let me go to this place, main.py, and I want to name, so this resource group, that's the name of the resource. That's how Pulumi identifies the resource. But I want to name the resource on Azure, not in the context of Pulumi, but in the context of Azure. So I have to specify the name of the resource group name, and I want to call it Adora resource local host conf. Right, I want to call it Adora resource local host conf so that we can see. And also, I want to call the app service plan. I want to call the storage account here. I want to call the storage account, the name of the storage account. I want to call it Adora Localhost. And then finally, I also, because we would see, when we open Azure, we would see the resource group, we would see the storage accounts. This is deployed inside of the storage account. So these things we will not see until we open the storage account. So we would see the resource group, the storage accounts. We would also see the app service plan. So I want to change the name of that. I want to call the app service plan Adora Localhost plan. If you are wondering, the reason why for the storage account I didn't put hyphen there is because storage accounts are not allowed to have hyphen in their names. So the final thing is the web app itself. So I want to name the web app Adora Localhost 23 app. I want to make it as unique as possible just in case somebody else in the world has something called Adora Localhost app. So now that we have this, remember the names, because we're going to go into Azure and we will find these resources. So now that we have this, we're going to run Pulumi up. I might need to do an AZ login first. So I'll do that off screen and then I'll come back. Yeah, so I've done my AZ login and I've cleared my terminal because I don't want to show what subscriptions I have and details about my subscription. But I'm logged into Azure now. So let's run a Pulumi up. And yes, we can use the dev stack. That is fine. I want to deploy it to my dev stack, to my dev environment. So it's showing me all of the resources it is going to create. And keep note of this. It's saying it wants to create a storage account. It wants to create a storage container, storage account static websites, a blob container, a blob, a web app, another blob, an Azure blob folder, and 2 other blobs. So these are like the things that it wants to create, and it's asking me if I want to go ahead. So I'm just going to say yes. Okay, so now we're done and we have the URL to our API and the URL to our website. But before we actually go into our website and our API, let's go into the Azure portal to see that these resources are actually there. As you can see, this is our resource, Adora Resource Localhost Conf, the resource group that we said we were going to create. We have our hosting plan, which is our app service plan. We have our function app, and we have our storage accounts. So now let's actually run the code and, use the function app just so that we can tell that it actually does work. So this is our static web app and it is asking what time is it? Ask the cloud. I already asked the cloud and I got this as the time. So let's try it together. As we can see, it works because the time is actually 12:37 right now. So let's try something else. Let's try to update our infra and see how Pulumi responds to updates. Then we'll also try and delete something and see how Pulumi would respond to it. Let's go back into Visual Studio Code. So from Azure, we know all the resources that we have. We have a resource group, app service plan, app service, and a storage account. But now I want to create a key vault. I have some secrets I want to store. So I'm going to create a key vault and I'll call it vault. So I would say vault equals Azure.key vault, and they have a fantastic documentation as well. So I've done Pulumi a lot of times. That's why I can write some things without necessarily using the documentation. But you can go through the docs. It's pretty self-explanatory if you do. So I want to call my vault, or let's call it key vaults, right? I want to set the location. Sorry, give me 1 second. I want to set the location of my key vaults. I want to set the location of my key vaults to maybe West US 2 because I think everything else is in West US 2. Let me confirm. It's West US. So I want to set my location to West US, and I also need to set the properties of this key vault. So I want to set the properties of this key vault. So Azure key vault vault properties, vault properties args. I want to set the access policies. So I can just set any access policy really. I need to use my object ID, I believe, to set these access policies or it's going to fail. So let me grab my object ID and then I'll be right back. So I have gone to pull out my object ID. So let me just type my object ID here. This is my object ID, and I want to give permissions. Oh, I'm supposed to put this in quotes. So I want to give permissions. I want to say that my permissions are like Azure Key Vault. I miss these things sometimes too. Permissions args. So I want to give certificates. Get and list. I want to give I want to give certificates get and list. I want to give my keys get and list as well. I can also add set and delete. But let's leave it at that. And then I can give my secrets get and list too. And this is done. So let me now go to here and set my tenant ID. Actually, let me come here and set my tenant ID. Let me come here and set my tenant ID to this. And once we've set the tenant ID, I think we're fine. I should also set my tenant ID here. I should also set my tenant ID here. But like I think we're fine after that. We just need to add the resource group that we're deploying to and the name of the key vault. So the resource group we're deploying to, we already have a resource called resource group, and that's the amazing thing about these things, right? So the resource group, we've declared it before, is called resource group. I can come back here and do resource group dot name, and yeah, it knows to fetch the resource group on my behalf. And I also want to call my key vault Adora key vault localhost, right? So these are the things that it is going to create on my behalf. I hope I got the IDs correctly so it doesn't throw an error. But even if it does, that would also be fun, right? Because at least we can see how Pulumi handles errors and things like that. So I want to show you how Pulumi updates things. That's actually the main reason for this. So I'm going to run another Pulumi up so that you know that Pulumi has a state file that it uses to track the current state of the infrastructure. So let's run Pulumi up again so that you can see how Pulumi manages states and knows when something has been created before. Also, I'm missing the school, sorry. So I need to add that here as part of the properties. So I'm missing the school Azure dot key vault dot school. So I want to do dot school args. So I want to do a standard one, right? So family. I feel like this is like the properties that I use for every single key vault I've created in my life. So we also have Azure the key vault dot school name dot standard. Fantastic. So this should work now. Let's run Pulumi up again. But at least we got to see how Pulumi handles errors. So you should never be afraid about mistakenly writing something that is not correct because you don't know if it will handle it. Pulumi would handle that for you. So let's now go ahead to run all of the things and let's see what happens. It has come back to say that there's only one thing to change. Actually, let me change the code. Let me change something in the code so it rebuilds the code again so that you can see that it would also come and tell you that it needs to update the container with the code. So it's saying, what time is it? Ask the cloud. Let me add something here that says hello there. Oh no, let me make it a yeah, sorry. And let me just say hello there. And then I want to say, oh, sorry. I want to say no in the terminal so that I can run Pulumi up again. And it would show me that you're about to update your code and you're also about to update your infra. So as you can see, there's one thing it wants to create and there's one thing it wants to replace. It wants to replace this blob because now the code has changed, just so that I can show you all of the magic. So now let's run updates and let's see what happens. It is done with the updates. So now let's go to the Azure portal and see what's there. Fantastic. As you can see, our key vault is right here. And let's also refresh this our serverless example to see if our new hello is showing. It is also there. Good. So I'm going back to Visual Studio Code to show you one more thing right now and to show you that Pulumi also knows when we are about to delete stuff. So I will delete the key vault right now and you would see that Pulumi would handle that delete for us as well. So it's not just only about updating things, adding resources. You can also remove resources and Pulumi knows when you want to remove something. Coming back here, and all I can say is the beauty of all of this is that it's written in Python, a language that you already know. If you don't know Python, you probably know TypeScript, you probably know Go, you probably know C#, and it's just amazing. And if you know all of these languages, it also has a YAML alternative, which you can tap into if you're a YAML person coming from a traditional DevOps background trying to do infrastructure as code. So this is amazing. For deleting, like regular code, when you are tired of it, delete it. So you either comment it out or you delete it, but we can get this out of the way. And once we get it out of the way, all we need to do again, I just deleted the block that had the key vault declaration in it. All we need to do again is another Pulumi up because we're updating the state. So Pulumi up basically means make my infrastructure look exactly like this code I just showed you. And as we can see here, it says there's one thing to delete and 12 are unchanged. Do we want to perform the updates? I'll just say yes. And it will perform the updates for us. And once it does perform the updates, we will go back to the Azure portal and see exactly how it happened. I'm at the Azure portal now and I have not refreshed the page. So let me refresh the page and let's see. Yep, it's gone. So this is how Pulumi works, and I hope that this has been useful to you. In case you want to try out Pulumi, you can join the Pulumi community or you can just reach out to me. I'm always happy to help. I am a part of the community and there are amazing people there as well, part of the community. And it's open source, like I mentioned, so you can get help from different kinds of people and everyone is always collaborating and trying to share knowledge. So yeah, I hope this was useful to you. Thank you so much for listening to this. I hope this was useful to you. Even if I am not here physically today, I am available on social media. If you have any questions, feel free to drop them on the timeline. My TL is faster than my Twitter DMs, right? So if you have any questions for me, feel free to ask me on the timeline and I will be more than happy to respond to your questions. Thank you so much and I hope you enjoy the rest of the conference.